So, our group was challenged to design and build a trebuchet that could launch a marble. Counterweights would be our only source of launching power. We had to include a throwing arm in our build. This kept us from building a catapult. There were a few design requirements that we had to meet. Our trebuchet must have been able to fit inside a 1-foot box with the arm being detachable. Then, we had to be able to reassemble it in less than 2 minutes. In our build process, we had to come up with an original design with at least 25% of it being made from a 3D printer or a laser cutter. The overall goal of our project was to design the most efficient trebuchet as possible. The equation for efficiency was mass of marble times the maximum range. This was divided by the mass of their counterweight times the vertical drop of our counterweight.
Okay. Research and design. Beyond the basic requirements, we wanted a good range. With that in mind, we looked for the maximum arm length and height drop we could achieve within the parameters, because these are the two factors most closely attributed to a good range. The theoretical maximum arm length was the square root of 3 feet long. We considered making it separable to increase that, but that was deemed too structurally unstable. We were afraid that it would fall apart. Instead, Trent suggested that we replace the short arm with a wheel. Doing so would decrease rotational inertia by swapping the counterweight's large rotational inertia for the wheel's smaller one. Since this would improve our energy ratio, we chose the wheel instead of the short arm. That required us to slightly shorten the throwing arm to about 1 foot and 3 inches. We settled on about 8 inches for the height drop of the weight because it couldn't really be much higher within the 1 foot parameters. This was our simulation that we did at virtualtrebuchet.com. We basically varied everything but the marble mass and the weight drop and the arm length. So this was the final result. It was the most efficient design that we could come up with, and interestingly, we did better than the predicted range during our tests. For the specifics of the release mechanism, we took realworldphysicsproblems.com's advice. We used a pouch configured as shown, with total string length of both sections equal to twice the long arm's length. The nail needed to be at a slight upward angle to achieve a 45-degree release angle, which would maximize the range and the energy efficiency. Here's the final design. It separates at 5 points of contact to allow dimensions of over 1 foot by 1 foot by 1 foot, but only barely. We decided to manufacture the wheel and throwing arm with the 3D printer since it's hard to make a perfect circle otherwise. That became problematic later on, but this is the research and design section.
Hello, this is Trenton Rush, and I will be talking about the construction of our trebuchet. The overall construction process went as planned, with some minor errors. We wanted to be different with our trebuchet by adding a large wheel instead of a short arm. In the beginning, we wanted to construct the wheel using the 3D printer, but weight and cost became a problem. Luckily, with Mr. McHugh's help, the idea to use the router became a reality. Because of this, we were able to customize the size of the hole in the middle of our trebuchet so we could use a larger dowel rod for support. Also, with the added weight of the wheel, we added 2 cross beams to our trebuchet for support. One other minor change was that we made from our original design was the platform on the bottom. We originally had 2 platforms that would be connected together so the marble would be able to slide smoothly over the surface when being pulled. But after discovering that there was not a problem, we removed the empty platform from our design. Our overall design is quite large. We knew that this would not fit into a 1 foot by 1 foot box without deconstructing it, so we made every part of our trebuchet collapsible. Using a multitude of latches and pre-drilled holes, putting the entire thing together is quite simple in a 2-minute process. Some ideas for a better design in the future are drilling a screw into the wheel to have a better and simpler way to support the weights, having a platform underneath that can support any extra weight that is added to test distance. And lastly, would have liked to discover a better way or maybe a larger pocket to hold and release the marble with ease from our trebuchet. Overall, our construction went quite smoothly with some minor changes.
The launch of our trebuchet was very successful. Trent would put the long arm down to the grass of the field and pull the marble right under the wheel. He would release the marble, causing it to fly. The first testing day we used a 1 kilogram weight. The marble went about 12 yards. Then we decided to use a 2 kilogram weight because that was the original design plan. When using 2 kilograms, the marble went about 18 yards. The second test that day with the 2 kilogram weight was not so successful. The long arm swung around with so much force and ended up breaking the long arm. The long arm was made out of balsa wood, which was very weak after so many tests. So we decided to use a dowel rod for the long arm, and it seemed to work much better. On the second test day, the marble launched even better than the first, with a distance of 20 yards. We continued to test that day, but were unable to match our previous results. The base of our trebuchet was breaking, and the weights were having trouble staying in the trough we made on the wheel. The efficiency ratio was 0.83 for the predicted ratio, which we used a simulation to come up with that number. After all the testing, we came up with an actual overall ratio of 0.997. Overall, our trebuchet performed very well and better than anyone would ever expect. We could have improved on our release angle and make stronger long arm to stop any breaks, but overall we're happy with the performance of our trebuchet.
And now for some videos of successful and unsuccessful test runs. In this video, our throwing arm falls off, so if you can see it, pay particular attention. And there it goes. Just flew right off. 2, 1, good.
I think we went